Hello everyone, welcome to the EnsolarX boiler room. As you can see, here we have a 120 liter boiler. There is another 100 liter and a 2 kilowatt heater. And today I will show you how to connect it to this device, that is, to the device that controls this application. And in the energy tab we have such an output from 0 to 10 volts in the device, which we will use to control this heater. At night we will limit its consumption to, let's say, minus 30 amps. And I will show you how to smoothly control such a heater so that when there is a load, it will regulate it more or less depending on how much we allow and how much we want to get from our photovoltaics from the warehouse to this heater. So what? Let's start. So today, as I said, today I will say I am not AI, so maybe it will be better. And look, today we will make it because here we have this relay for smooth regulation from 0 to 10 volts. This is an SSR, not an ordinary SSR, but an SSR with a smooth regulation input from 0 to 10 volts. With this SSR, here with these two wires, we supply a signal from 0 to 10 volts. And depending on how many of these volts there will be, at the output of this heater, it is connected in a loop. It is like an output like a relay. It kind of cuts off the sine wave. But never mind that. It regulates the power in the range from 0 to the maximum of what we have connected at the output. And at the output of this relay is connected that heater, which I showed you a moment ago. There is a 2 kilowatt heater there. And now look, me, for example, because in this latest version something like this came out that we can control this heater in the energy tab. We have such options in which we set what the power limitation on this heater should generally look like. So I have set that the maximum current from the battery should not exceed 30 amps. There was no such thing before, because if the consumption appeared below 0, i.e. it already saw minus 4 amps or something like that, it would immediately drop the output 0 from 10 volts to minimum. How do we know it's to minimum? Because you see there are two sliders here, and these sliders are set in such a way that I have it set from 1,600 to 3,000. So for me, it means like this. See, at the output from 0 to 10 volts, if you see here how I have the arrow with my hand, let's say how it goes. When this indicator goes up, let's say here we have 1 volt, 2, 3, 4, here it's 5 volts, 6, and so on. Only that some of these relays react in such a way that, for example, when we have 2, 3, 4 volts at the input of this relay, it doesn't open the output as if. Some react like this. Only these good relays, and this one is not good, react as if from 0, i.e. E, in the full range. And that's why I have it set here to a minimum of 1,600, you see, with this lower slider. This lower slider is adjustable, and with this slider we indicate to it from what value it kind of opens for us. Starts to open this relay and starts like this from 1,600 to 3,000. It works in this range, so when it's 1,600, it's open to 0. When it's already 1,800, it's already 1 volt there. I mean, it's already catching 100, 200 watts there, but at the input of the relay, it's already somewhere around 5.5 volts, and that's only just starting to open it. That's why I have it set like this. If I had an inverter, I would set it from 0, because inverters already work well in this range from 0 to 10 volts, and it would already start spinning something here at 100 or there at 200. It would already starting it with this heater. But in my case, it's just like that. I have it. It starts there above 1,600. And look, we have current. The maximum current from the battery can be, I didn't let it draw more than 30 amps. This is possible now. It wasn't possible before. From version 620 firmware and in 5.583. If I'm not mistaken, this is only possible. So if it's below 30 amps, it should immediately drop. Do you see this upper slider? This is it, shows how much we have this output controlled now, and it automatically regulates it itself. So you see, I have it controlled now to 2,260, and because look, I allowed it to give a maximum of 30 amps, and it will be, you see, it oscillates within these limits. It already has 32 amps, so now it has already seen here a little bit that it has a little too much. So it has reduced it by 28, and it should add it a little bit, and it will be floating somewhere within these 30 amps. At the bottom, you can see the parameters from the BMS, but as you can see, it does not match the ones at the top because I have two storages connected in parallel, and here goes 31 amps. The first storage takes 20, and the second takes 11. So in total, it is rather within 30 amps. That is why you're wondering here why the data from the inverter and the data from the BMS do not match. So yes, we have 30 amps and here we have the patient. I prepared it for the needs of the film kettle. We'll turn on the kettle in a moment and see what happens with this slider. Because it's controlled, you see at 2200 now, so when I turn on the heater it should immediately pull it down here. And if the difference in amps is more than 20 amps, it will very quickly pull it down here to below, and if it's less, well, it will just tick, tick, tick down a little and so on. Only now we'll turn on 2 kilowatts for it right away. So this difference, well, we'll see how big it is in a moment, so it should quickly push it down. So as you can see here, the output energy is 1,495 watts, just like here in the tab. What you can see here is 1,486. Well, I won't switch it because we can see the same thing here. The output energy in the energy tab is 1,602 watts now, right? So we won't switch to that window when we turn on the kettle. We'll just be here on this tab and now see 1,570 watts, but that's only because I have a limit of minus 30 amps. Let's give it a limit of minus 50 amps. I'll write down this data and we'll see what it does. We'll wait until it writes it down. And there's a second condition. You can see it marked here. The minimum battery voltage is 50 volts. So if the voltage on the battery drops below 50 volts, it won't let the heater turn on either. So it'll pull it down. Okay, it saved the data, it'll pull it down to the minimum, and now look, it saved the data of 50 amps, and do you see? It's already pulling up here 1,270. 2,270, and this slider will be there. You see it's slowly pulling it up by itself. I'm not touching anything here. It's already 1,700 watts. I'll go to this data one window so you can see 1,700 watts. And there the rest of the house is drawing around 2,500 watts. So here in total the heater should appear at a maximum of 2 kilowatts. So here it should be about 2.5 kilowatts. It shouldn't draw any more because there's not that much reception. So we've already got minus 45 amps coming from the battery, 47 amps. We'll go back to the energy tab. Here we've already got 2,495. With this we already have, you see here we have 2.5 kilowatts, and it will continue to drive here. It will even reach 3. But this consumption is already more like 2 kilowatts. It will not be 2.5 kilowatts. It will not go because there is no such reception, because he has already pulled 2,000 of this heater to the maximum plus those 500 that are more or less from the house. So we have, as we see here, it will not be more than 2.5 kilowatts. Okay, let's give him minus 20 amps here, and in a moment we will turn on this kettle. Minus 20 amps. So now after recording he will have it. Oh, it recorded and he should drop it here right away. Let's see for ourselves at the output. Minus 48 amps more. Oh, we already have minus 15 amps, and you can see it now. He dropped it here to the minimum, 1,465, okay, 1,600. Current consumption, how much current consumption is it? Minus 18 amps. Let's see where it's going to oscillate here. It should pull it up a little bit. Okay, so minus 20 amps here is a little too little. You see we have 2 kilowatt. 20 amps is times 50 volts is 2 kilowatts. 2 times 5 is 10. So, okay, we'll give it another go. We'll bring it up a little bit to 30 amps. It should go up. So you see, it sees the consumption from the storage. And now when we turn something on, we'll give it a little bit more. Let it get to 30 amps here. Let's give it 18.5 amps. Another reading, because this is a reading every few seconds, 19 amps. We're going to look at this strip, this slider. We can see that 1,700 is going up slowly now, slowly pulling it up. Here we already have 957 watts. We'll wait a moment until it gets to 30 here. We'll rewind a bit so you don't have to wait. Okay, we have 27 amps and we'll get to 30 here in a moment. For now, I'm not going to do anything to see 30 amps, and now it shouldn't be going here anymore. It can catch 32 at the top there. You see 29 and 8, and at this value it should oscillate. Well, okay, let's turn on this kettle. See, I've got it. I'll turn it on. It's got 2 kilowatts, so it should appear at the output. Maybe I'll show you. I don't know if it's okay to show you because there will be a faster refresh. Or here, I'll show you here on the app. Here we have 1,500 watts. We turn on the kettle and we'll see what it shows us here. We have 2,170. There was a control. Tick. It immediately went down to 1,600, which means it turned the heater off to minimum. The heater is ticking off, you know. The point is that it exceeded the value that we allowed it to. Now we have minus 52 amps together with this, with the kettle. Okay, now we'll turn off this kettle and let's see that. You see, it won't let him turn it on. No, the maximum was, now like this, we have 861 watts. That's how much the rest of the house draws. And you can see that since I turned off the kettle, the current consumption is 30 amps lower. So now it will slowly draw up this heater for us. And generally it will work the same way during the day. Only the thing is that now it is possible to do as if on the minus. You can set the amperage in this energy tab. Here the maximum battery current. These parameters and these sliders apply only and exclusively to the output from 0 to 10 volts. And now look like this. I have set here, as you can see, that this sensor from 0 to 10 volts. Oh, now it's night. Look, the sun sensor now gives us 6 because it does not give, even at night when it is completely dark, it shows the minimum value of 5 or 6. So for it to work at night, even this output from 0 to 10 volts, we have to set it to 2 so that it works below this value. Because if we set it from 10, well, it would have less than 10, so these 5, so it would immediately turn off this output from 0 to 10 volts. So we have from 2 in the full range to 3000. I don't have to mark this window, this little check mark here, because if it's not marked, it works from 2 to the maximum, so up to 3000. If I marked it, it would work exactly the same way as it does now, but if I had, for example, from 2 to 2000 here, it would only work in the range from the minimum to the maximum. So if it exceeded the maximum, it would also turn off the output from 0 to 10 volts. And if it's marked even after exceeding those 2000, it won't turn off this output as if to 0. So it's generally better. It's probably better to have it turned off. It depends where, in what situation, who needs it. It's better to have it turned off and operate in the full range from up to 3000 because it won't give more of these EnSolarX from the sun sensor anyway. Because this is the value from the sun sensor that we have, what we have, how many of these EnSolarX we have. In this case, if we have it set here, you see, use the data at the bottom from the sunlight sensor. These are the values that we put here. These are values in EnSolarX. So we move in this range. So our battery won't let us, EnSolarX won't let us turn on the heater if the load is greater than 30 amps from the battery. If the voltage is greater than 50 volts, then only then will it allow it. So these two conditions must be met. I also have it set here that if the state of charge is greater than 30%, only and exclusively then should the output from 0 to 10 volts work. If I have it marked, you see here in this line from 0 to 10 volts, I have one more condition added. All this will only work if this condition is also met. So if, for example, you set that if the price per megawatt hour is less than 600 zlotys per megawatt hour, then it will also react if this price falls below this value. So look, MJA, now a moment has passed. We've reached it back. You see this slider here. That is our value at the output from 0 to 10 volts, again, to our 2200 almost. Let's go to a given one. Let's see the load is minus 30.1 amps, and as you can see, it's standing here. I'll turn this heater on again. Cut. And what will happen to us? See? We'll wait a moment. What will it do? It will show a greater consumption. It's minus 60 amps now. It will see the second reading of 52 amps. You see, he's already turned the heater off because 2 kilowatts plus those somewhere in the range of, I don't know, between 500 and 800 the house draws. That's 2600. The heater is off now. He's pulled it off completely, as you can see here. Well, nothing's going on anymore. I'll turn it off, and so on. So if we were to turn on some 500 watt load, it would pull it off for us, for example, up to 1900, let's say, right? Only the condition would have to be this negative amperage would have to be met. You can also set this positive amperage, for example, only that then it doesn't make sense, that above 2 amps only if it goes to the warehouse. Well, only then so that it controls this heater for us. Only this doesn't seem like a reasonable solution to me, because once the storage is full, it won't pump to the storage, which will tell EnSolarX to turn off the heater. And we have power from the panels, so giving plus values here is probably a bit, I don't know, unnecessary. It seems to me that these values should be at least minus 1 ampere, minus 2 amperes, something in the minus. But yes, but this minus 30 ampere is for the reason that, for example, look, I'll show you the graph. I'll go back one day. Look at this yellow graph. This is the consumption. You see in the evening here, when someone goes to take a shower, well, this heater, you see it turns on. Look here, it's 2 kilowatts exactly. 2 kilowatts, and here she is. When the tank reaches a cooler temperature, she discharges the storage here, but not with a current greater than, I had it set to minus 40 amps yesterday. That's why you see 2 kilowatts here. And the next day we see here, somewhere here after 12, somewhere it turned off for a moment. I don't know why. And here again, at about 2:30, it finished heating the water. He finished heating the water, or he finished heating it, because you don't know that, but I can tell you that my storage tank here has already discharged to 30%.
At 2:30, because when I got up in the morning, I saw that the storage tank was discharged to 30%, and that's why it stopped heating the water anymore. Because I have it marked here that if the state of charge is greater than 30%, then only then, you see, in this line I have, this heater output is supposed to work. And that's why it happened that he discharged this storage tank there to 30%. He left me such a small buffer, because I knew that in the morning it would be sunny again, so that I would have that 30% somewhere there in case there was a failure or something. But we were supposed to have the sun, so you can see him back. He's already reached full, and now he's discharging it again, because it's 10:40 p.m. Now, as you can see, the water is already heating up again, and someone has already taken their first shower there. The water is already cooled down, so, so here the heating has already started from the heater. This is one of the maneuvers that you can perform using this output from 0 to 10 volts. So, if you use this output, focus on these two fields, minus 30 negative amperage, battery voltage, so that it doesn't, no, no, discharge too much, because if you can also have a situation where, for example, you have an inverter connected, but you don't have a BMS, so it doesn't know what the state of charge is, right? No, your system doesn't know what the percentage of your storage charge is, because the inverter itself doesn't know that. So you can additionally protect yourself so that it doesn't discharge the storage voltage, for example, below 50 volts. If the storage drops, well, then we don't want to turn on this heater, and then it will pull this slider down to the minimum as much as you set it here. Well, so as you can see, that's probably enough for today, as far as smooth control of this heater is concerned. As you can see, here you have new skins, in this latest app, 612. You can change it here, you can change the skins, you can see here at the bottom, um, style is under the tongue, and here you have a few such skins that you can choose, which ones you will like the most. For example, there may be one on the phone, or there in the application, and which one will suit you. This you can choose, because I was already getting signals somewhere to change something graphically, so I had to do it finally. So that's enough for today, and of course if you liked it then subscribe, because on this channel here we often talk about this device, basically mostly about this device. And this is this device. Here you can see various peripherals are connected. It is connected here at the moment to this die inverter. It reads data from this inverter, from this JK inverter, BMS. From this, the second solar reads from this BMS here, because here are two energy storages, and it gives everything here. You can see how, as you can see here on one page, you can see all the data from the BMS, from the inverter with a few seconds of refresh delay, so you can see that it all works. Here is a quite large list of inverters with which it works, so you can familiarize yourself with the topic on this channel. There are many videos on this topic. Take a look if you are interested, give it a thumbs up, and in a moment there will be some new materials. What new things will we be implementing in this device here? And soon there will be such a quite interesting thing. Well, I think that some people may be interested in it. So I invite you to subscribe, and we'll hear each other in the next episodes. Greetings to all. Thanks for your time, and until next time, take care. Bye.